Force in motion. Chapter 1, In Motion. All matter in the universe, things you can see and things you cannot see, is in motion. If you look around, some movements are easy to see. A car zooms down the highway. A train roars past on its tracks. A skater guides on smooth ice. A batter hits a baseball and sends it flying. Some motion you cannot see. You cannot see the movement of the earth around the sun or the movement of the planets. You cannot see the movement of the blood through your body. You cannot see atoms, the smallest bits that make up matter. Atoms combine to form molecules. Atoms and molecules are too tiny to see, but they move. Molecules in motion. Molecules move by vibrating. But at a very cold temperature called absolute zero, they don't vibrate. When the temperature gets down to about negative 459.67 degrees Fahrenheit, the motion of molecules stop completely. Push and pulls. Force causes motion. A force must push or pull an object to cause it to move. When you kick a ball, a push from your foot causes the ball to move. When you run, the ground pushes against your feet. When you move a shopping cart through a supermarket, you are the force that pushes the cart. Force causes all kinds of motions, such as rolling, sliding, hopping, gliding, moving forward, and moving backwards. Force can slow things down, speed things up, and change the direction that things move. Force can also act upon some objects to change their shapes and sizes. Force can squeeze, squish, crush, tear, bend, twist, or press objects. If you pull a rubber band out as far as it goes, you are using force to stretch it. During a baseball game, when a batter hits a ball, the force of the bat changes the shape of the ball. The ball flattens the outside of the ball for just part of a second. Inertia. Nothing in the universe moves because it wants to. All matter has something called inertia. That means it remains where it is and only moves if something causes it to move. Some kind of force must overcome the object's inertia before it will move. Once set in motion by a force, an object will go on moving even after the force no longer acts on the object, and it will move in a straight line. We say that an object that keeps moving in the same direction has momentum. It will continue its momentum until a force causes it to stop, slow down, speed up, or change directions. Have you ever been in a car that came to a sudden stop? You probably felt like you were being thrown forward. Actually, there was no force throwing you forward. Momentum is what caused you to go forward in your seat. A force stops the car's momentum. In turn, the car's seat belt exerted a force to stop your momentum. It's a good thing you are wearing your seat belt. Scientist of significance. Isaac Newton. Isaac Newton is considered one of the most influential scientists who ever lived. He was the first to figure out how forces cause motion. In 1687, he published his 3 laws of motion. Newton's laws of motion. An object speeds up, slows down, or changes directions only if a force acts on it. In other words, an object moves with constant speed in a straight line or stays exactly where it is unless a force causes it to change the state of motion. How quickly an object changes speed and/or direction depends on how much mass it has and how hard the force is pushing or pulling. Every action has an opposite and equal reaction. When you run, your feet push against the ground, and the ground pushes back against your feet with an equal force. But the force on the ground is pushing in the opposite direction against the force of your feet. Chapter 2. Gravity. One of the most important forces in the universe is gravity. It is the force that holds objects, including you, against the earth. Gravity pulls everything on the earth towards its center. If you jump up, you always drop back to the ground. Without gravity, everything on this planet would float off into space. All matter has gravity. The force of gravity between a large object such as Earth and an apple is much stronger than the force of gravity between a smaller object, such as your body and the apple. The moon also has gravity. It is much weaker than the gravity on Earth. The sun has a powerful force of gravity. The sun's gravity is so strong that it keeps the 9 planets from leaving our solar system. Scientists use satellites to study gravity. NASA launched twin satellites in March 2002. The mission is called the Gravity Recovery and Climate Experiment, or GRACE. The 2 satellites orbit above the Earth about 137 miles from each other. As they travel around the Earth, the pull of Earth's gravity changes the distance between the 2 satellites. The change in the distance tells scientists how much pull Earth has on the satellites. The satellites are making detailed measurements of the Earth's gravity field, which will be led to discoveries about gravity in Earth's natural systems. The scientists' data from the GRACE mission will be used to estimate global modes of Earth's gravity field. The mission is scheduled to last for 5 years. Weight and mass. Weight is a measurement that shows how much force gravity pulls on an object. When you stand on a bathroom scale, you see your weight in pounds. How much you weigh is how much force gravity is pulling on you. If you weigh 50 pounds, you are being pulled towards the center of the earth with a force of 50 pounds. Weight is a measurement of gravitational force. The weight of an object changes depending on how far the object is from the center of a second object, such as the Earth. The farther an object is from the center of a planet, the less it will weigh. Mass is a measurement that shows how much matter an object has. The mass of an object does not change. The force of gravity on the sun, the moon, and on other planets is different than the force of gravity on Earth. For example, Mars has a weaker gravitational force than Earth does, so a pencil will weigh less on Mars. However, the pencil will have the same mass on Mars as it does on Earth.